Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be calculating simple and compound interest. Before we do, let's review exactly what interest is. Now, with interest, you can earn interest or you can pay interest. When you're earning interest, this means when you save money in the bank, a bank will pay you a small percentage of the amount in your savings account. It's kind of like a thank you for letting them use your money. Now, you can also pay interest. When you borrow money or use a credit card, you will be charged a fee for the privilege of using someone else's money. This extra fee is also called interest. Now, there's two main interest formulas that we will be concerning ourselves with in this course. The first interest formula is simple interest, and our second interest formula is compound interest. Let's look at the formula for simple interest first. So our formula for simple interest is I is equal to P times R times T. In this formula, the I represents the interest earned, or the interest paid. The P is for the principal. Now, principal is your original amount. So let's say you deposit $5,000 into a bank account. The $5,000 would be your principal or the original amount you invested. Now, the rate, we need to be careful with the rate. This is our interest rate. I'll just abbreviate interest here. Interest rate as a decimal. It must be expressed as a decimal. And our T is our time in years. And that's going to be very important in this lesson. The time expressed as years. Simple interest is interest earned or paid only on the principal or the original amount. Now, our compound formula is a little bit different. It doesn't start out with the letter I, it starts out with the letter A. A is equal to P times the quantity 1 plus R to the T power. So in this formula, A represents your final account balance. Your final account balance. The P again stands for principal or the original amount. The R is your interest rate as expressed as a decimal. And T is the time in years. Now, compound interest is interest that's earned both on the principal plus any previously learned interest. So in general, your money will grow quicker with an account that pays compound interest versus an account that pays simple interest. So in example 1, it says choose the correct formula and then solve each problem. So in part A, it says Jason deposited $5,000 into a savings account that earns 4% simple interest. So you should either underline or highlight this right here because this is telling you, it's giving you a clue as to which formula to use. So in this formula, we'll use the simple interest formula, which is I equals principal, P, times the rate, R, times the time, T. Okay? Now, in this problem, we want to know how much will be in the account after 10 years. So we do not know how much interest this account earns. I'm just going to put a question for the I. The principal was his original amount, or 5,000. The interest rate is the percentage expressed as a decimal. So remember, 4% would be 0.04 when expressed as a decimal. And the time is the time expressed in years, so our t would be 10. So now we're going to plug in our values. I is equal to the principal, which is 5,000, times the rate, which is 0.04, times the time, which is 10. Now, generally, you're going to want to use a calculator for these. So I've got my Desmos calculator pulled up here, and let's just try this. 5,000 times 0.04 times 10. You should be able to put it in there all at one time. So our interest earned was 2,000. Now, the question did not ask us how much interest will Jason earn. It asked us how much will be in the bank account. So to get the account balance, you have to take what he originally deposited, which was 5,000, and you have to add the interest that he earned, and that was 2,000. So our final account balance in this problem will be $7,000. In part B, it says Macy deposited $2,000 into an account that earns 3.5% interest compounded annually. Now, grab a pencil or a highlighter, and I want you to highlight how the interest was earned. In our previous problem, our interest was simple interest. In this problem, it tells us it's compounded. So we're going to use our compound interest formula that we wrote down up here. A is equal to the principal times the quantity, 1 plus r to the t power. So we do not know how much will be in her account after 5 years. So I'll put a question mark for account balance. We do know the original amount was 2,000. We know her rate was 3.5%, but we have to express it as a decimal, so that would be 0.035. And we know the time in years was 5. All right. Now, when we plug in our values, we'll say the account balance is 2,000 times the quantity, 1 plus 0.035 to the 5 power. Now, when we type this in to Desmos, we'll put 2,000 parenthesis 1 plus 0.035 close parenthesis, and then I want to use my little exponent button here, and I want a power of 5. Now, I'm going to round this to dollars and cents, so this would be 2375.37. So her account balance at the end of 5 years would be $2,375.37. Now, if they were to ask you how much interest did she earn, this is the account balance. If they were to ask you how much interest she earned, then you could just take her account balance, 2375.37, and subtract off the original amount, and that would give you the amount of interest she earned, 375.37. Okay. All right, let's look at a couple more examples. Mr. Jenkins deposited $1,250 into an account that pays 4.25% annual simple interest. So I'm going to stop right there and highlight the type of interest we have in this problem. So the formula for simple interest is I equals P, principal, times rate, R, times time, T. Okay. If he made no additional deposits or withdrawals, how much money would be in the account after 36 months? All right, in this problem, we do not know the amount of interest he earned, but we do know the original amount, or the principal, was $1,250. For the rate, 4.25% expressed as a decimal would be 0.0425. 0.0425. 0.5. And the time, now be very careful here, because they gave you the time in months. But according to our formula up here, the time needed to be expressed in years. So we need to convert 36 months to years. Now, if you've forgotten how to do that, just take your 36 months and divide it by 12, because there's 12 months in a year. 36 divided by 12 just gives me 3 years. So our time is 3. So a lot of students make the mistake of using that 36 for the time, but you want to be sure to convert it to years. So if I plug in my values, I have I equals my principal, 1,250, times my rate, which is 0.0425, times my time, which is 3. So I'll plug this into my calculator. 1250 times 0.0425 times 3. And that comes to, if I round to dollars and cents, 159.38. Now, in this particular question, they want to know how much money will be in the account. This 159 only represents the interest earned. So to find the amount of money in the account, we have to take what they originally put in, which was $1,250, and add the interest earned, which was 159.38. So 1250 plus 159.38, and that gives us a total of $1,409.38. Let's look at another example. Ben deposits $1,750 into an account that pays 2.75% compounded annually. So I want to highlight that because that's telling me to use the compound interest formula, which is A equals principal times the quantity, 1 plus the rate, to the t power. If he does not make any additional deposits into the account, how much interest will he earn at the end of 24 months? So in this problem, we do not know the final account balance. We do know the original amount was $1,750. For the rate, 2.75% would be 0.0275. And for the time, we need to take the 24 months and divide it by 12 to get 2 years. So when we plug in our values, we'll take the principal, 1750, times 1 plus the rate, which is 0.0275, to the 2 power. So when I put this in the calculator, 1750, 1 plus 0.0275, use my exponent button, and power of 2. So I'm going to round this to dollars and cents. The account balance would be 1847.57. Now, let's answer the question that was asked. The question says, how much interest will he earn at the end of 24 months? So if we want to find the interest earned, we have to take the account balance, which is 1847.57, and subtract off what he originally deposited. So 1847.57 minus his original amount, 1750, and that tells us he earned $97.57 in interest. All right, last problem. A business owner deposits $4,500 into each of the 2 savings accounts. Account 1 earns 5.5 simple interest. Account 2 earns 3.5% interest compounded annually. What is the combined balance for account 1 and account 2 at the end of 3 years? So let's start with account 1. For account 1, we're using the simple interest formula. So that would be I equals P times R times T. We do not know the interest. We do know the principal was $4,500. We know the rate would be 0.055, and we know the time is 3 years. All right, so if we plug that into our formula, we get interest equals $4,500 times the rate, which is 0.055, times the time, which is 3. So this account earned $4,500 times 0.055 times 3. So the account earned $742.50 in interest. Now, if we want to know the combined balance for account 1 and 2, we need to calculate the account balance for account 1. So let me write that down. Account balance. To get the account balance, you take the original amount deposited, $4,500, and add the interest earned. So $4,500 plus 742.50, and that would give me $52.42. So that's the amount in account 1 at the end of 3 years. Now let's calculate account 2. Account 2 earns 3.5% interest compounded annually. So that means we want to use our compound interest formula, which is A equals P, parenthesis, 1 plus R to the T power. So we'll take our principal, which was $4,500, 1 plus our rate, 0.055, raised to the, oh, excuse me, I just almost made a mistake there. This account has a different interest rate. This account pays 3.5% compounded annually, so that would be 0.035. And the time is still 3 years. All right, let's calculate that. 4,500 times 1 plus 0.035. Use my exponent button to the 3 years. So the account balance will be $49.89 and 23 cents. Now, the question is, what is the combined balance in the two accounts? So let me write this down. If we want the combined balances, we're going to have to take the account balance from account 1, $5,242.50, and add the account balance of the second account, $4,989.23. So 5242.5 plus 4989.23 to get a total combined balance of $10,231.73. And that concludes today's lesson, calculating simple and compound interest.